Hi there, welcome back to Chem with Go. Today we're going to take a look at valence electrons. Before we get into what the definition of valence electrons are, some people would argue that valence electrons are actually the cause of all chemical reactions, or if almost all chemical reactions. I know organic chemists definitely would agree. But let's go ahead and define what valence electrons are. These are the outermost electrons in an atom. Outermost electrons. And they're usually at the highest energy level. Okay, they occupy the highest energy level within an atom. There is a rule for valence electrons, and the maximum number of valence electrons an atom can have is 8. And if you understand the organization of the periodic table, you would note that valence electrons are usually identified by the S block of the periodic table and the P block of the periodic table, which is this section right here and then this section right here as well. Okay? So now that we've got an understanding of how to identify, where the valence electrons are in the periodic table, as you go across, you'll note that there are 2 columns in the S block, and those stand for the S orbital electrons, and there are 6 columns in the P block, and that identifies the 3 P orbitals that are present, or the 3 P electrons, pairs of electrons, I'm sorry, that are present in the outermost energy level. All right, so let's go ahead and clear this. Let's take a look at the second row, or the second period of elements in the periodic table, starting with lithium. And you'll note that lithium has an atomic number of 3. So that means it has 3 protons, 3 protons, and 3 electrons. I know it doesn't have a charge, so if we take a look at lithium, in its first energy level, there should be a total of 2 electrons right here. And this will be the nucleus right there. And on the second energy level, there happens to be 1 electron in its outermost energy level. So the number of valence electrons lithium has is 1. So it's 1 valence electron. Because it has 1 on the second row, or the second energy level, and it happens to be located on the first column of the second row. So the column actually identifies, just as long as it's in the S or the P block, the column identifies how many valence electrons it actually has. That's the sort of the beauty of the periodic table. It tells you, just by the position of the element on the periodic table, how many valence electrons it has. Okay? Let's take a look at another one. On the second row again, let's take a look at fluorine. Fluorine has atomic number 9. And if we take a look at the number of protons and electrons this thing has, this is 9 protons and 9 electrons. Now, because it's on the second row, it would have filled up the first row of electrons already. So fluorine, on its first energy level, will already have 2. 1, 2. And if we move on to the second energy level, if we take a look, that's 9 minus 2 electrons. So now there's 7 electrons left, and there happens to be 7 valence electrons for fluorine. So we just put 1, 2, 3, 4, 5, 6, 7, and 8. Oh, sorry, not 7. Not 8, but 7. There you go. Cool. And also, an interesting thing about valence electrons is that the number of valence electrons actually helps define what the properties, the chemical properties, and also the physical properties of what that element or what that atom would do. And we'll talk more about that in class, about the number of valence electrons and its chemical and physical properties of these elements. Okay? We'll see you then.